So yesterday we were examining from an intuitive level this notion of parabola. So we began yesterday's investigation looking at these tools to create and generate a curve. Once we had that curve generated, we tried to use what we knew about what the tools could do to show that we've got this sort of parabolic shape, and we believe that it's parabolic because of the reflections preserving distance relationships. And we tried to connect then both the enactive and the iconic to the symbolic with the academic language, where we were defining parabola as all points equidistant from a point to a line. Now most students, and probably even you to some extent, most strongly identify parabolas with this function idea where the independent variable x is being squared. And how we often go about looking at parabolas is starting with this symbolic representation of something being squared, and we generate some ordered pairs. We plot those ordered pairs, and then we draw the curve, and we see that the curve does indeed create this parabolic shape. So we're going, once again, this time we're going from symbolic to iconic. And, that's great. That's how a lot of people think of parabola, but you'll notice that what we did yesterday actually didn't connect to most people's common notions of parabola, which is this x squared notion. So as we attempt to go from an iconic representation to a symbolic, one where we can state the function y equals something times x squared plus something blah blah blah, it's interesting to begin to note that it only takes 3 ordered pairs to determine a quadratic, a second degree function. So for example, the curve, the parabolic curve that would go through these 3 points is x squared plus x plus 2. Now unfortunately, there are lots of curves that actually go through these 3 points, and most of them are not parabolic. So you'll notice that here's another symbolic representation. This is a cubic that actually goes through those same 3 points. So you can see that it can be very difficult to try to determine why the picture in fact generates or is connected to a quadratic symbolization. So we're going to try to explain and prove specifically that this representation it does indeed generate what we would say is a parabola, something that looks like an equation that can be written in terms of x squared. So let's start by actually describing these 2 points, the focus being 0k, and the points along the curve, which will be changing. So these have to stay, x and y has to stay the real variable in the equation. K is sort of a dummy variable. It's a generic number, but it's not variable. So one of the things that's important when you think about proofs is there's a difference between when you assume things for a proof, which is you have to take things on faith, and when you suppose things in a proof. So the supposition being you are purposefully stating that this point is at 0, k, because you know that it doesn't matter where this particular point lies, because we could translate this shape anywhere we wanted onto the coordinate system. That's very, very different, supposing something because you know that it will not make a difference, versus an assumption where you take something on faith, and in fact you need to go back then and explain why, if it wasn't true, what would happen. So be very careful. There's a difference in proofs when you make an assumption versus when you make a supposition. So we're supposing that this is at 0, k. Because we know it won't matter. We could translate this parabola wherever we wanted onto the coordinate system. That being said, we can now determine what the distance is between the focus and a point on the curve, and from the point on the curve down to the directrix, which we will consider to be the x-axis again. This will be our supposition. So you notice that the distance between the focus and the directrix is right here, the square root of x squared plus the quantity y minus k squared. And the distance right here from the directrix to the point on the curve, x comma y, the distance would be y. Because we're trying to view that we are looking at this as if it was a parabola, we know that from our work with reflections from yesterday, and from our proof, our geometric proof from yesterday, we've got y squared equals x squared plus y minus k squared. I've set those distances equal to each other. That was our proof from yesterday. Remember that these distances were the same. And then I just squared both sides. Doing a little bit of algebra, I get y squared equals x squared plus y squared minus 2ky plus k squared. Doing a bit more algebra, we notice that we've got y squared on both sides, so they will cancel each other out. Taking the negative 2ky to the opposite side, we get 2ky equals x squared plus k squared. Dividing both sides by 2k, we get this isolation of y equals 0.5 over k times x squared plus 0.5k. Aha, look at that. Yes, indeed. We have shown and we have now connected the geometric to the symbolic, not symbolic academic language this time. We've connected to the symbolic squiggles for what it means to be a parabola.